Have you ever wondered what linear regression is and how it works? Perhaps you've heard the term thrown around in conversations about data analysis or predictive modeling and wondered how it fits into the grand scheme of things. Well, wonder no more. Today, we're going to delve into the fascinating world of linear regression, breaking it down in a way that's easy to understand, even if numbers aren't really your thing. Imagine you're a fruit vendor trying to predict how many apples you'll sell tomorrow. You look at your sales records for the past few weeks and notice a pattern. On days when the temperature was warmer, you sold more apples. This is a simple example of a linear relationship. As one variable, temperature, increases, so does the other, apple sales. Now, let's take this concept a step further. Linear regression is a statistical method that allows us to study the relationship between two continuous variables. In our fruit vendor example, these variables are temperature and apple sales. By plotting this data on a graph, with temperature on the x-axis and apple sales on the y-axis, we can draw a line, or regression line, through the data points that best represents the relationship between these two variables. This line is the crux of linear regression. It's a predictive model, suggesting that for every unit increase in temperature, there's a corresponding increase in apple sales. The slope of this line represents this relationship and is known as the coefficient. The point where the line crosses the y-axis when the temperature is 0 is called the intercept. Together, the coefficient and the intercept form the equation of the line, giving us a mathematical representation of our observations. However, real-world data isn't always as neat and tidy as our apple sales example. There's often noise or variability in the data, leading to deviations from our regression line. This is where the residuals, the differences between the actual and predicted values, come into play. The goal of linear regression is to minimize these residuals, creating the most accurate prediction model possible. So, to recap, linear regression is a statistical tool used to understand the relationship between two variables. By plotting this relationship on a graph, we can create a predictive model represented by a line, the equation of which is determined by the line's slope, the coefficient, and y-intercept. The accuracy of this model is determined by the residuals, with smaller residuals indicating a more accurate model. But remember, while linear regression is a powerful tool, it's not without its limitations. It assumes a linear relationship between variables and may not be the best fit for data that exhibits a non-linear relationship. However, when used correctly, it can provide insightful and useful predictions. So, next time you're trying to predict apple sales or any other variable, don't forget about linear regression. It might just be the tool you need to make sense of the data and make accurate predictions. Who knew statistics could be this fun and interesting?